CloudIMQP provides RabbitMQ as a service, and internally we really heavy on RabbitMQ, and a huge number of our events pass through RabbitMQ, and of course we eat our own dog food and therefore use CloudIMQP in our own production. This talk aims to give an overview of the automated process behind CloudIMQP and how RabbitMQ has enabled us to evolve and improve our service over time. My name is Lovisa, and this is my colleague Anders, as I would say in Swedish. As you can see, we both enjoy hanging around in the mountains while we're not tweaking RabbitMQ configs. And feel free to ask us any questions about skiing, snowboarding, RabbitMQ at any time during this conference, or even interrupt us during this presentation. So what we would like to do today is take you out on a journey back to 2012. A simpler time, some might say, but not for all. For one, there was no hosted RabbitMQ service. Our first goal was to provide RabbitMQ as a Heroku add-on, and we knew that we wanted a microservice architecture for all the common reasons like flexibility, loose coupling, and so on. So we started out with a RabbitMQ server, some Heroku API endpoints, a database to keep track of stuff, an AWS integration, and messages like account create and account delete, to a lesser extent, thankfully, started flowing through our Rabbit. And we were off. As it turns out, users will misbehave, or at least some users will misbehave. Someone could easily create millions of queues or connections or channels, cause RabbitMQ to crash, and you need restarting. And as a paying customer, you kind of want to get alerted when your server is close to exhausting the limits of the server. And all these user requirements led us to create services for monitoring and alerts. Eventually, after some time, as a small startup, we found it a bit sad, giving 30% of each subscription to Heroku. So we were thinking that maybe we should add our own customer portal that also could produce account delete and account create messages. And slowly, the number of rabbits in our rabbit farm started to grow, as it also does in a normal rabbit farm. Soon, we started getting requests to support other cloud providers, and therefore we created a few more subscribers for our create and delete messages and added support for DigitalOcean, Azure, SoftLayer, and Rackspace, just to name a few. And even though giving 30% to Heroku made us a bit sad, we realized that this actually gave us really good exposure. And 70% of $1 is still much more than zero. So we added endpoints for a bunch of other marketplaces. And with more and more RabbitMQ servers running, both we and our customers needed to have better insight into the state of Rabbit. So we added services to ship logs and metrics. And in both those cases, RabbitMQ was our very good friend. To collect the logs from all the servers we had, we utilized the RabbitMQ log exchange and created shovels to our own Rabbit. And we could then add consumers that forwarded these logs to a centralization service of choice like Papertrail and Loggly. For metrics collection, we created a service that pulls virtual memory statistics, free disk space, use and free memory in the system, and also data from the RabbitMQ management interface, and publish this to Rabbit. And we could then add a number of useful services that uses these metrics. And for example, we could ship them to external services such as Datadog and New Relic. We could also put them in our own time series database to provide charts and provide more sophisticated alerts, such as Q matching X has not had any consumers for Y seconds, or alarms that indicated connection or channel leaks, and warnings about unrouted messages and so on. If you now start to wondering or worry that CloudAMQP relies on just one single RabbitMQ server, I want to clarify that this is actually, in fact, several servers. One for business events, one for logs, one for metrics, and so on. However, we simply thought that all these slides would look much better with just one single server.
Okay, thank you, Louisa. So one thing that eventually started to annoy us and our users was the lack of progress feedback in our web console. For very quick tasks, we could rely on the built-in RPC support in Rabbit to get feedback back to the browser. For example, enabling a plugin in RabbitMQ. It's really fast, so we could just do that with an RPC call. But for longer running tasks, we had to figure something else out. For example, when you want to upgrade RabbitMQ version, you had to refresh the browser to see if the version number changed to know if the task had completed or not. That might have been okay in 2012, but not so nice today. So we started including the session ID of each user-initiated message, and had our consumers publish some task progress messages that a new feedback service could forward to the user's browser via a server-sent event connection. Another option we considered for this was to use RabbitMQ's built-in WebSocket support, but that would mean that each page view on our web console would create a new RabbitMQ connection, so we opted for this kind of proxy for the feedback. Once we had solved that, we, over time, continued to add more cloud providers like Google Cloud Platform and Alibaba, and even more sales channels, such as Azure and IBM Marketplace, and even more metrics and log integrations like Libredo and CloudWatch. And because we publish all our business events and metrics into Rabbit, it's been real easy to just continue to add new services that operate on existing data. And we've been able to progressively improve our service without much risk of breaking existing functionality, although that might have happened on some occasion. But we take great care to never break anything. That's in the lower right corner there, where our customers' actual servers are. It's been very rewarding working in an architecture like this, where we have been able to keep a quite high pace, been able to answer customer feature requests with yep, that's done, hours after receiving the email. So the requirements on our different services, like the metric service and monitoring services, have changed quite a bit over the years. The metric service, for example, in the beginning only had to process a few messages per minute, while now it processes thousands of messages per second. And as all you developers in here know, we stay away from premature optimization. So this has led to quite a few rewrites of some services. But luckily, this neat architecture centered around Rabbit made such changes fairly easy. So with Rabbit, we really feel that we have the flexibility to choose the right tool for the right job. Our services are written in several different languages, and we have the possibility to scale services independently. Some services might need scaling vertically, and some might need scaling horizontally. And another really neat feature is that things break independently of each other. This architecture has also served us really well as we have grown from one-man company to a company of 20 people over these past 7 years. As one team can be working on the metric service, while another team is working on adding a new cloud provider without any interference. And it's also been really easy to onboard new developers into this kind of architecture. They can take on one service at a time and progressively learn more and more about the entire stack. So looking at this architecture, there's actually not much that's limited to providing RabbitMQ to our end customers. So we have since started providing PostgreSQL as a service, and Mosquitto, which is an MQTT broker, as a service, and also most recently Apache Kafka as a service. All using the same architecture. All we really had to do, apart from learning the ins and outs of these other products, was to add a few more consumers. One that installs Kafka instead of RabbitMQ, one that gathers Postgres stats instead of RabbitMQ stats, and so on. If you wonder why the Kafka service is named Karafka and not Kafka, it originally was, but Confluent and Apache didn't approve. So that's the story behind that. But as this is a RabbitMQ conference, I will stop plugging those other services. After 7 years and managing about 5,000 RabbitMQ servers, with a total of 60,000 accounts, as some of our plans are multi-tenant plans, we've been able to gather some interesting statistics about the typical and maybe not so typical RabbitMQ user. First, let's have a look at what versions people are running. As you can see, most users are still on 3.7, which is not so surprising since 3.8 has only been out for about a month. But quite a few are still on 3.5 and 3.6, and actually some are happily on 3.3 still, living by the motto, if it works, don't touch it. So how are people using Rabbit? In this chart you can see that the left bar for each type is the maximum of any given server, and the right is the median value. And I think all the median values look quite reasonable, like 19 bindings, 7 exchanges, 24 queues, nothing crazy. And I was wondering if this is true for this crowd as well. Who here is using more than 24 queues in their servers? Almost half, so yeah, within the margin of error. One thing to note from this is that most people seem to stay away from policies and separating access with vhosts and users. we actually provision our servers with 2 vhosts and 3 policies and 2 users. So it seems like most people just leave it like that and don't use those features that much. Some words about the maximum values you can see here. I peeked in a little bit on these clusters, and it looks like this one cluster with 94,000 bindings haven't really learned about routing key wildcards. So we might have to educate them about that. And the top exchange cluster with 150,000 exchanges, that just looks weird. They're all fan-out exchanges. I couldn't figure out a good reason for that setup, but we might have a nice user story coming there. And for the top users cluster, it looks like all their end users get a RabbitMQ user as well. I'm not entirely sure that's a good idea if their business sees some rapid overnight growth. And some messaging stats. The fact that RabbitMQ performs best when queues are short seems to have reached most users, which is nice, while someone seems to have confused Rabbit for a database with some 400 million queued messages. And we can also see that most users don't use Rabbit for high-frequency messaging, as the median value for delivery and publish rates are both really close to 0. And we can also see that most messages are routed to more than one queue, as the delivery rates are a few times higher than the publish rates. And I also took a look at which clients are the most popular. So this is the breakdown from a snapshot of 600,000 connections. And we can see that a couple of different Python clients, together with all the Pivotal supported clients, are the most popular. And we can also see that Python and .NET are quite fragmented, as they have 3 different clients each in this top 13. And these 13 different clients stood for 99.9% of all those connections. But even though Python is a very popular language these days, this made me wonder if counting all connections like this is a fair comparison. Maybe some Python client is written in such a way that they create a lot more connections than other clients. So I instead only counted the most popular client on each vhost. And then the stats looks like this instead. As you can see, the Python clients dropped quite a bit, especially the Pika client, that went from 17% of all connections to only being the most popular client on 4% of the vhosts. So I think this is a more fair way to look at it. We shouldn't endorse being sloppy with connections. And finally, we can group that on language instead, and see that Node and Python and Java are the most popular languages, which is not a big surprise, perhaps. Maybe it's also true for this crowd. Who here is using Node for their Rabbit clients? Not really. Python? A few more. Java? Okay. Yeah, that's, or maybe we have to see who is using Erlang. Yeah, a few. Yeah, that's all we had prepared, so we're happy to take any questions.
Hi, thanks for the talk. These are really interesting numbers. What would you say is the most common support query that comes in from clients using your service?
Most common support question. Huh? Could be like they have made their cluster run out of memory, or
I think
that's pretty common. Misusage of RabbitMQ in some way. Need help to figure out why that happens.
Thank you.
So, did I get that right? Your hosted Kafka, Cloud Karafka, is supported by an RabbitMQ backend?
Yes.
That's a nice tidbit.
Exactly. Actually, we do have a Kafka cluster in our architecture as well. So we're dog fooding there as well.
I have two questions, actually. Are the Rabbit servers that you're running Dockerized or running on actual bare-bone instances in all of the cloud providers that you support?
No, Docker, it's bare-bone instances, yeah.
Do you notice any performance bump? Have you tried actually to run it on Docker and then seen like a performance penalty, and this is why you opted in for the bare-bone, or?
We actually haven't profiled on Docker, so no.
Another question, it was not in your slides, but it would be an interesting statistic for me. If you know how often queue sharding is used and how performant that is on a cluster it's running on, by any chance.
How popular what is?
How often the queue sharding plugin is enabled on a cluster.
Okay, yeah.
And whether this queue sharding provides the expected throughput for the client that requests this plugin.
Yeah, we might have to do a follow-up talk next year with some more statistics.
I'll be covering that in my talk. So. I do have a question, actually. I was just curious, for the highest throughput customer you have, what's the hardware that runs on?
The what?
The hardware.
Hardware.
Network cores.
I didn't go into that. We can have a look at that later.
Okay, just curious.
Any more questions?
So this is another statistics one.
Yep.
I would be interested to know what the average size message you get put through. I'm assuming you don't have those to hand, but it would be very interesting to hear about.
No, unfortunately, I don't have that at hand, but yeah.
Sounds like we will need to give a talk about all the statistics we have next year. Only.
But I would imagine it's quite small.
Okay, thank you so much, Anders and Lovisa.
Okay, thanks.